You already know this, but you may have never truly thought it through. Right now, at this very moment, you are hurtling through space. Not slowly, not gently, at 107,000 kilometers per hour around the sun. And at the same time, the Earth is spinning beneath your feet at over 1,600 kilometers per hour, if you are standing at the equator. And the sun itself is flying through the Milky Way at 220 kilometers per second. You feel none of it, no vibration, no wind, not a single sign that you are on the fastest journey anyone could ever imagine. This is not something to take for granted. This is one of the deepest puzzles in physics, and when you truly understand it, not just as a fact, but as a mechanism, as a principle, the way you see movement, perception, and nature itself will never be the same. Let us start with what your body can actually detect. Your inner ear is a masterpiece of evolution. It senses acceleration, changes in speed or direction. It detects when a car stops and suddenly speeds up. It registers when an elevator goes up and then comes to a halt. It picks up the turbulence of a plane in rough air. But it does not detect smooth, steady movement. It does not feel constant, unchanging motion. This is not a flaw. This is physics. And this physics has a name. It is called the Galilean principle of relativity, and it is one of the most fundamental principles in all of science. Galileo Galilei put it this way in the 17th century. Inside a closed system moving at a constant speed, there is no experiment that could tell you whether you are moving or standing still. No physical experiment, none at all. You could hang pendulum clocks, drop balls, pour water into glasses, watch flames. None of it would reveal whether the ship you are sitting in is anchored in the harbor or gliding smoothly across the sea. This sounds simple, but think about what it really means. Motion, smooth, non-accelerating motion, only exists relative to something else. There is no absolute stillness, there is no privileged state of rest in the universe. When you say I am sitting still, what you are really saying is I am still relative to this chair, this floor, this earth, but relative to other stars, other galaxies, you are moving at a speed no human mind can truly grasp. Here is the deep consequence of this. The earth does not suddenly accelerate. It does not jerk or lurch. It rotates and orbits the sun, and it has been doing so for billions of years in a steady, stable rhythm. Your body, the air around you, the oceans, the buildings, everything moves with it. Everything shares the same reference frame. Imagine a train carriage moving at 300 kilometers per hour along the tracks. If you stand inside it and drop a ball, the ball falls straight down, not backward, not sideways. To you inside the carriage, the ball falls perfectly normally. The ball shares your motion. It has the same inertia. It is part of the same reference frame. The earth is that carriage, only bigger, much bigger, and older, and faster. Newton's first law describes this precisely. An object remains at rest or in uniform straight-line motion unless a force acts upon it. That is inertia. And inertia means this. If the earth has been carrying you since the day you were born, at a constant speed without a sudden stop or jolt, then there is no force to alert your nervous system. No force, no sensation. But there is something that often confuses people. If the earth rotates, does it not constantly change direction? Is that not technically acceleration? Yes, that is correct. The Earth's rotation and its orbit around the Sun are, strictly speaking, accelerated motions, centripetal accelerations, directed toward the center. But these accelerations are so tiny relative to the mass and inertia of the system that your nervous system cannot detect them. The centripetal acceleration at the Earth's surface due to its rotation is roughly 0.03 meters per second squared, less than 0.3% of normal gravity. Your body simply cannot resolve that, and yet there are traces. Physicists and engineers know them well. The Foucault pendulum, a pendulum that swings for hours and slowly rotates its plane of movement, reveals the Earth's rotation indirectly. The Coriolis effect, which steers hurricanes and ocean currents in specific directions, is a direct consequence of that rotation. These effects are real, measurable, physically significant, but they are so slow, so vast in scale, so far beyond the range of human time perception, that our bodies can never feel them directly. What I find so fascinating here is what this tells us about perception itself. Your senses were not built to perceive reality directly. They were built to detect change, and specifically changes at the scale relevant to a living creature on the surface of a planet. A predator approaching, a branch breaking, the ground giving way. For these things your senses are finely tuned. But galactic speeds, planetary orbital paths, these lie so far outside the scale for which evolution ever built a sense that there is simply no signal to send. And that leads to a question that never stops occupying my mind. How many other realities are passing through us right now, silent and invisible, not because they do not exist, but because our senses were simply never tuned to receive them? Electromagnetic fields are moving through your body at this very moment. Neutrinos, nearly massless, nearly non-interacting particles, are streaming through you at close to the speed of light, trillions of them every second without you noticing a thing. The cosmic microwave background radiation, an echo of the Big Bang, surrounds you from every direction. You sit still, you feel nothing, and around you a universe races through time. That is the real wonder. Not that the Earth moves, that is physics, that can be measured. The real wonder is that this motion is so completely, so perfectly embedded in the nature of space and inertia that no living creature on this planet could ever feel a trace of it. Galileo said it first, Newton gave it equations, Einstein deepened it into the theory of relativity. And today, as you sit in your chair and look out the window, you are witnessing one of the oldest, deepest, and most beautiful principles in physics, that smooth motion and stillness may be physically indistinguishable. You are moving at 107,000 kilometers per hour, and you will never feel it. That is physics. That is nature. And it has always been this way, even when you never noticed.